Hey there, I'm Lokesh and today I want to dive in the world of 3D scanning with you. For some of you, this might be new and others might already be an expert. However, 3D scanning can simplify and improve your workflow to fulfill your inspection tasks. With hands-on methodology, we want to support you, inform you and explain what 3D scanning is and how it can make a difference for you. Even more importantly, we want to guide you in choosing the right technology for your application. Especially the 3D scanning market developed immensely and there are many different technologies on the market. The most important thing is that understanding that every technology has its own strength in a certain application. Let us first start with the basics of 3D scanning and why it's getting more important. If you look at today's product and the way products are designed, engineered or manufactured, the complexity of the products is increasing. But also the need to inspect them or to create digital archives to reduce the cost of the storage is growing. In this case, you can tremendously benefit from 3D scanning. It enables you to make a digital copy of your part and you can use it wherever you want in the lab, in the production environment, or in the field. 3D scanners are three-dimensional measuring devices. They enable you to get complete or partial digital 3D measurements of any physical object in order to analyze or to remodel them. Instead of the traditional point-by-point measurement devices, these devices generate a point cloud of 3D points without needing to touch the object while capturing the data. The scanning results represents the real object using free-form unstructured three-dimensional data. As mentioned, this can be in the form of point cloud, but most scanners deliver a triangle mesh directly. Images or the so-called individual scans are brought together by the operating software into a common reference system and then merged into a complete model. Most of the time, this is performed automatically during the scan or has a separate post-processing step. The result is triangulated mesh. Objects are usually scanned to create a digital mesh for additive manufacturing. The mesh acts as a base for extracting dimensions to reconstruct a CAD by reverse engineering as well as to measure an object for a different analysis, inspection and documentation purpose or digital archiving. In general, we could divide the 3D scanners into two different technology categories based on the way they capture the data. Structured light systems, or to be more specific for our solution, fringe projection systems and laser scanners. As mentioned before, each technology has its strength in certain application. With handheld laser scanners, you follow the shape of the part by moving the scanners around it. The projected laser lines on the part are detected by the cameras and this results in 3D data. The technology focuses on on-site applications where portability is key. One example might be MRO task where scanning a pump or a valve at an oil refinery is crucial for creating spare parts. If you are, on the other hand, looking for highest accuracy and detail in 3D scanning, our heterodyne fringe projection is your go-to-go technology. It gives you a lot of information with just one scan. There's no need to follow a shape of the part when scanning. It projects a pattern onto the part quickly and two cameras will calculate the 3D data. A great technology for automated and semi-automated scanning process. Before you make a decision, let's delve into both options and examine the various factors that could influence your choice. As 3D scanning is becoming more mature and widely used technology, you might ask, how reliable and accurate is the solution? Can I go to the part or do I need to bring the part to the system? Can I transport the system or is it completely handheld? Also important is the flexibility of the solution compared to the parts I want to measure. This is especially important if daily 3D inspection tasks involve different types of parts, different sizes, various materials, and objects with different levels of detail. Ease of use is one of the system's key strengths. It allows people with different skill sets to easily work with the system. The software ZEISS Inspect is also designed to be intuitive with a clean interface and easy to follow workflows. Although 3D scanning is a complex technology, the solution needs to ensure simplicity for both hardware and software. We often hear questions like what level of knowledge is needed for 3D scanning and how easy it is to operate the system. And this is where our semi-automated 3D scanning solution, ZEISS ScanPort, combines ease of use with beginner's friendliness. In the upcoming videos, we will go deeper into the above mentioned factors and look how ZEISS ScanPort improves your inspection semi-automatically. If you have any questions about the basics of 3D scanning, please reach out to us via support@handsonmetrology.com. For more getting started information, be sure to check out our other videos. I hope you found this introduction to 3D scanning technology and ZEISS ScanPort informative. Thanks for watching and see you next time.